Hey everyone. So my presentation is about migrating to state and shared flows, and my name is Mohit Sarveiya. I'm a GDE in Android and Kotlin. It's been a while since I presented in person, so let's see how this goes. So in this presentation, what I'm going to share with you are the fundamentals, the foundational pieces that you need to know about state and shared flows that will help you to implement features. So for the past 3 years, what I've been working on is helping companies like in a large team on backend on Android utilizing shared flows, and I'll share with you from my experiences, tips and tricks. So the most important thing to understand first is that what is the difference between a cold flow and a hot flow. So this is something that stumps many people when they start to utilize flows. So a cold flow is a type of flow that always completes. Whenever you subscribe to it, it goes through all the operations, how you have set it up, and it will always complete, and it will always give you a consistent answer. So let me give you a very simple example of a cold flow. And here's an example. It's very simple, using flow of emits 3 items, 1, 2, and 3, and you have a map operator. And if I were to collect from this, it's going to go through and emit the first 3 items, go through the map operation, and then it's going to collect and give you the result. And what's important to understand is that after the emissions complete, this flow will complete, there is an incomplete extension that you could intercept that's going to get called. And that's a behavior of cold flows. It's not a behavior of hot flows, as we'll see. So if I have another subscriber that, if I were to collect from this flow again, is going to start up again by emitting the 3 values, 1, 2, and 3, and then apply my map operator, and then it's going to complete. So when you look at hot streams, so they don't complete. That just this, as I showed you with the cold flow, the on completion block doesn't get called, and after all the collections. And there's also have this property where they exist independent of subscribers, meaning that you could collect from the flow at any time, and so it's completely independent of how many subscribers that you have. And in the coroutines library, there are 2 ways to model hot flows. And in Android, we use state flows a lot to be able to model, to have a stream of UI states. You could also use shared flows a lot outside of your view model layer. So these are 2 ways, and I'll go through how do you utilize both of these different things. So first, let's start with a state flow. So what I'm going to show you are different ways that people set up in their architecture state flows, create this type of create a state flow, and the properties that it has. So suppose you had one approach is suppose you had an MVVM type of architecture where you have a view model that's communicating, interacting with the view, and you have a state flow. You could have a state flow exposed from your view model to your view, in which this flow, each circle represents a UI state. So you can model your UI state in different ways using data classes, field classes. So here, this is an example. I have a UI state with the loading, with success, and error. And what you would do then, the next step, is to go in your view model. You could use Android X view model, and then you could create a state flow like this, manually create it. And then what a state flow requires is to have a default value associated with it. In this case, is loading. So for example, like suppose you had a fragment that has a view model. The fragment starts up, the view model instantiate. The first thing that's going to emit is going to be this default value of loading. So you could have a null. You could also specify a null if you want. But that comes with its drawbacks. You have to handle that nullability on the view side. So how do you push to this state flow? And there are different ways to do it: suspending ways, non-suspending ways. And one way to do it is using an emit method, which is suspending, in which I am passing in, for example, a successful state. So every time I transition from one state to another, I'm going to push to my state flow. The another way to do it, which is non-suspending, is to use dot value. So one thing important to understand is that when you push something to a state flow, it caches the most recent item that you had sent to it. And recently in Kotlin coroutines library 1.6, what they added was in a method. This is the recommended way. They added a method called update, and it's thread safe. This is a recommended way to push things to a state flow. And one other pattern that's used a lot is to use, for example, your UI state and use the copy method to generate a new instance of a state, and then push it to the state flow. So that's the basic of creating a state flow and pushing to it. And how do you subscribe to it? So usually one pattern that's followed is that you do state flow that you would take your immutable state flow and do as state flow, which gives you a read-only version that you would give it to your view. And the purpose of having a read-only version is that on the view side, the fragment side, you don't want anything to push to the state flow, only from your view model side. And you would collect from the state flow like this. So in this case, I have two subscribers. And whenever you have a subscriber that subscribes to the state flow at any time, it's always going to give you the most recent item that was pushed to it. That's important to understand. So another thing to note, which is the most important thing, which trips a lot of people up and source of a lot of bugs, is that if you were to push in your view model side layer if you were in sequentially multiple things, on the fragment side, where you're going to get was only the emission, which is the most recent emission, the last emission that you sent, it does conflate emissions. And one thing in helping people resolve bugs, the question comes up, well, why didn't I get a certain emission on my view, a certain emission, because it was conflated? So it's very similar to RxJava distinct until change method. So if I were to collect from this, I would get error. For example, I'm not going to get the success. So it has this feature of conflation. So when you're building out, when you have this archetypal architecture and you're building out your logic, most people, in their use cases in the vModel layer, you're usually combining multiple flows together. And these flows, they could be from your database side, they could be from your API side, and you're combining them together, and you have some logic to determine what the UI state is going to be. The most used I found in a lot of use cases, the most used operator is flow combine. And it's very important to understand flow combine and how that works. So let me give you an example. So here is an example of two flows that I'm combining together. So they could represent like API or database, and if both of them emit something like a letter A or 1, then you could have some logic to determine what happens when both of those items get emitted. But you could also have an instance where one of the flows emitted something, but the other one didn't. And if that happens, it's going to take the previous emission and give you that back. So then you could define a logic, and you'll get 2A back. Similarly, for this, you get 2B back. So that's how flow combine works. And And you're merging flows together on your vModel side. So you would define some form of logic to declare, come up with the UI state, and then you would collect, and then you could push to the state flow. So that's one way to do that. There are other ways that I'll show you that you could also, without using collect and without emitting, there are other ways to create a state flow with the combine. I'll show you that people use. So when you write out for your feature or whatever you're working on, the logic on your vModel side, something that's been really helpful to me is using flow marbles. So if you're in RxJava, you have those marble diagrams. There's equivalent to that, there's flow marbles, and it's interactive. So, and you could look at basically how any of those operators work, what is the expected behavior. And that's been really helpful to me. So what we looked at is the Google recommended approach of setting up a simple MVVM architecture with a state flow. And we're using the state flow to communicate UI states. But let me share with you another approach to create a state flow in an architecture. And the approach that I'll share with you is the approach based on this library at Square, at Cash App, called Molecule. And this is a library that uses Jetpack Compose to build state flows. And this is, when you think about that, is that Jetpack Compose is not just the UI toolkit. It's not just for building UIs. You could utilize the compiler, the Jetpack Compose compiler APIs to do other things. And it taps into that to be able to create state flows. And which is really nice. So this is an example of using Compose for non-UI related work. So the approach that you would take with this library is this is the approach where you're still combining multiple event flows together. And these event flows could be from the API, from basically the database, etc. But what the difference in this approach is that you're creating a composable function that determines what the UI state is going to be based on what those events emit. And what this library provides is an extension on a scope called a molecule. And and the name may be weird, but it's what that extension does internally is it taps into the recomposition snapshot APIs. And it has logic in there to be able to push to that state, to a state flow, whenever new events are emitted. So this is a similar approach, a different approach than what I showed you earlier. So let's look at an example how to utilize this approach. So with this approach, you could declare a presenter. I'll show you also how to use this with the vModel. And this presenter is a composable function. And what it takes in is, you could take in 1 or 2 or 3 event flows. And what do you have in here is logic to come up with what the UI state is going to be. So I'm using collect that state. And collect that state in this example is null as a default. And over here, I have some simple logic to come up with loading or whether you have some particular data. So this right here this composable function should be executed anytime then a new event is emitted. And what I'm going to do is that I'm going to create something called a molecule. And the way this works is that so the molecule is an extension which will give me back a state flow. And the way this works is that first thing you want to do is create a scope. You could use a vModel lifecycle scope if you want. And on that scope, you're going to utilize this extension called launch molecule. And it takes in a Lambda block, which is annotated composable. And in there is where you're going to provide, basically inject in your logic, which connects basically the event flow to the UI state. And it gives you back a state flow. So, and you could pass this flow, you could pass it to either your fragment. You could use XML. You don't have to use compose with this. You could also pass it with compose. So this is a pattern that I have used, and you could set up scaffolding for this for your presenters to be able to do this right here, to be able to provide a UI state like this. So that's something pretty cool. So suppose that you were utilizing a view model. One of the feedback that I got is that when people hear presenters, they think of MVP, and you may want to use Android X view models. So Chris Baines, he has an app, an open source app called TV app, and he has a good example of utilizing this pattern with Android X view models. And here he's creating a state flow by using the launch molecule extension. And he has the logic in there in which I'm basically coming up with some UI state. So you could also follow this pattern with Android X view models. So that's another way to create state flow. So if you want to learn more about how that works underneath the hood, what Compose APIs is that tapping into, the library is pretty simple to understand. It's not a lot of code, just one file. And you could check out my talk. I gave a talk on at Chicago meetup, and it goes over all that. I also do live coding in there and provide an example. So what we looked at are different ways to use state flows, how to create them, like set them up in your architecture. And the next thing that I want to look at, which is my favorite flow, a shared flow, which has a lot more features. And I commonly have used shared flows a lot on backend development, and on Android, like outside of your view model layer. For example, for creating like publisher-subscriber type of architectures. So similar to a state flow, a shared flow is a way to send out events to multiple consumers. And these consumers, they could be coming in, subscribing at any time, and I could push events to it. But what I could also do with a shared flow is the ability to replay events. So for example, suppose you had a use case where you have a subscriber that's going to subscribe to this shared flow at some later time, and I could replay previous events that were pushed to it. So it also has the ability to cache what you've been sending. You could specify how big that cache is going to be. You could specify or look at what happens when this cache gets filled up. So that goes into back pressure. So how do you declare a shared flow? And it's very different than declaring a state flow, whereas you don't specify a default value, a starting value. But there are other things through the constructor that you could configure. So let's look at an example of reading from a shared flow and pushing to it. So what I have, imagine, this could be imagine you had some scope you declared and you launch a coroutine on it, and I have a subscriber that's waiting to read from this shared flow. The collect gets called and is suspending, and the coroutine stays suspended. And then I have a coroutine which is responsible for pushing basically to this shared flow, emitting events to it one by one. And I emitted the event of 1. And this is going to my other coroutine, which is waiting, and is going to get that event. If you ever want to know how many subscribers you have at any point, you could do flow.subscriberCount.value, and you could know. So in this case, you have 1 subscriber here. So, but suppose that you had an example where you had a delay. There's a delay in which this coroutine gets suspended, and then you go ahead and collect from this flow. But suppose during that delay, you have this other coroutine in which you are pushing things to it, and you pushed event 1. And does the other subscriber receive, when it goes to collect from the flow, does it receive a value? It doesn't receive a value at all. And why it doesn't, when you push to this shared flow, in this example, the subscriber count was 0 because you had the other coroutine that was delay. It didn't subscribe to the flow at all. So one of the features that you could tap into, as I was saying, is the ability to replay, specify a replay count. Whenever a new subscriber comes in, and I want to set up a replay, so the replay is 0 by default. You could set it up by 1, 2, and 3, and it's going to internally cache at least that amount of items that you're emitting to it. So in this case, with the replay of 1, then you'll actually get something in the collect. So it's a very simple example of pushing things to shared flow and receiving things from it. You always want to do this from 2 separate coroutines. One is the producer, and then you have like n number of subscribers. So the other thing to note is that I have a subscriber here. The collect gets called. Unlike a cold flow, the onComplete method of this flow will not get called. And so it's not like a cold flow, and that's important to understand. And like in a cold flow, when this 3 items are emitted, this onCompletion will get called. So, but there's one thing that's important to remember. If you're building some type of a client, for example, that's handling, sending notifications out, at some point you want to clean up your subscribers. And otherwise, it's going to cause memory leaks. And you want to clean up all these coroutine jobs that you're launching for your subscribers. And that's really important. And when you cancel them, it will ultimately complete the flow due to an exception. It doesn't complete it normally without an exception. So that's an important feature to understand. And so that was the basics of being able to set up and some of the features of shared flows. So one of the things, so shared flows are a replacement for broadcast channels. So before shared flows, there was something called broadcast channels. Broadcast channels were deprecated. So I remember working on a code base where a lot of the things that were used were broadcast channels. So migrating from broadcast channels to shared flows was actually very simple. There's a simple one-to-one mapping. So you might be in that scenario. So let's compare the APIs of both of these different things. And what they did was something that was in one motivation was that to provide simpler APIs than the channel APIs that are provided to you by broadcast channels. So when you declare a broadcast channel, you could declare like this. You would declare 10 is like a cache size. I want to cache 10 things, so I'm going to send to it. And then you would use the suspending version of the channel, like channel send, channel close. And whereas on a shared flow is much more simpler. There's no idea of closing a flow. There's only an emit method. So it's much more simpler to use than broadcast channels in terms of its API. And the other thing that shared flow has is this feature of being able to replay, which is not in a broadcast channel. So in terms of both of these constructs have this ability to specify a buffer size. So for example, it's 10 here, but with the shared flow, you could also specify like an extra buffer capacity. So in this case, I could store about 12 emissions that I could send to it. So when you were to compare both of these, they added shared flows, to make it simpler, and migrating from a broadcast channel to a shared flow is pretty simple. The way you map it one to another is that suppose you had a broadcast channel, and you're somewhere in your code, and you specified a capacity to it. And this maps to a mutable shared flow, and that capacity maps to an extra buffer capacity. So this would be the mapping from one to another. And then wherever like you have instances where you're pushing things out, you could use the mapping for the emit and try emit. So try emit is the non-suspending version, emit is the suspending version. So from experience, migrating from one to another was pretty straightforward. So the next thing that I'm going to share are flow sharing strategies. And this is another way to be able to create a state flow. And this is a way to convert cold flows to hot flows. And basically what it is that, so I remember working on with someone on a feature, and they implemented in their view model, they had multiple flows that they were combining. Like a room has support for flows, right? And they were combining multiple room flows and coming up with some UI state. And what they did to create the state flow that they ultimately give to their view to observe, they utilized a extension called state in. So they didn't declare a state flow manually themselves. State in is an extension that returns a state flow for you. So these are two different ways to create a state flow. You could use the state in extension, and these are extensions on the flow. So share in is an extension on the flow, which gives you back a shared flow. And what's interesting about them is that you could specify the behavior of what's going to happen if someone were to subscribe to a flow by using these things. What happens when they get started? And you could specify different behavior based on your use cases. So for example, suppose I had a flow, like maybe I'm combining multiple flows together and I did .share in to create a shared flow. The first thing that I need to give is some external scope that you would create. Internally, what share in does is that it launches a coroutine on that scope to listen to listen to the upstream flow that I have here. So then you could specify a replay count. So this is for share in. And then you could specify what happens when it gets started. And there are 3 types of policies. They're called policies. There's while subscribe, eagerly, and lazy. And while subscribe has its own behavior feature set. So I know I'll show you how it behaves. So this gives you back a shared flow that then you could use. So there are 2 properties of while subscribe if you were to use that. And what it specifies is that this flow is going to be active as long as that external scope is alive. And it's always also going to be active as long as you have subscribers. These are two of the properties of it. So let me show you an example what I mean. So suppose over here I launch a coroutine while using this scope, which is listening to the shared flow. It's suspended there because collect is a suspend method. It's going to suspend this coroutine. It's going to wait for emissions. And suppose that you take this external scope that you gave in, and then you were to cancel it. If you cancel this external scope is going to clean everything up, and it's going to complete your shared flow, your subscriber that you have. So what that means is that if you build something like a client that's using this shared flow, very important, like in your on destroy or whatever, is to cancel that external scope. You could have an architecture where you're not utilizing view model scope. You're creating your own scope, in a separate, way. So and good to clean up and by canceling that scope. So the other thing is that it's all as active as long as there are subscribers. So for example, suppose you had a shared flow like this, and I'm intercepting the onComplete method here. And if I were to have a subscriber that's listening to the shared flows just as before, and if I were to cancel one of those subscribers, it's going to complete this shared flow right here, that this subscriber that I have. And it's also going to complete my upstream flow also. So if I had 2 subscribers and one of them stayed open and the other one was canceled, this shared flow doesn't complete. That on-completion block won't get called. It's going to stay open because you have at least one subscriber that's still listening. So that's important to do, because if you don't clean up properly, then you will get problems. The other sharing strategy is called eagerly, and suppose that I specified that. The way this works is that when you create, like in a class, this flow like this using share in, is going to start the upstream flow right then and there. It's not going to wait for any subscribers to come in to be able to subscribe from it. So you'll see that when this gets executed, the on start will get emitted very quickly, right when it gets created. So eagerly starts the producer really, really fast. Whereas lazily will actually wait until you have at least one subscriber in order to start the flow. So it starts the flow at least when there's one subscriber, and you would initialize it like this. And then when you call, this on start won't get printed out at all, just like an eagerly strategy. It will basically print it out when at least one subscriber happens. So this is very similar to, for example, in a coroutine context, you could specify lazy and then do job.start, similar to that. So, and then you'll see that on start gets printed out. So this is lazily. So these are the 3 sharing strategies that to be aware of. And based on your use case, you would pick one of them. I mostly you would use while subscribed. The last thing that I want to go over is managing back pressure. So shared flows you have the ability to specify how many items you want to cache that you emitted to it. But suppose in this type of a setup where you have a producer and n number of consumers, you could have a producer that's generating events really, really fast, but your consumers are slow. They may have a delay in their coroutine. They're not able to process each event. So in that case, all the events that are generating will be cached in this buffer. So suppose it's slow to listen to the events. So in this example, I have a cache size of 3. So it's going to fill up 1, 2, and 3. But then what happens when this cache gets filled up? And the great thing of handling, managing back pressure in coroutines is simpler than RxJava, and for me, in my opinion. So you could, take advantage of 3 different types of strategies to manage a buffer overflow. When it fills up, what happens? And there are 3 ways: suspend, drop oldest, drop latest. What suspend does is that this is the default strategy, which is it will suspend the coroutine until there's room in the cache. So that's one way. That's the default way of doing it. And when you create a shared flow, it will set this for you, set these parameters for you in this example. So here I have a cache size of 2. It will store at least 2 emissions. So yeah, it's cache size of 2. So suppose you had an example where you emitted to the flow 1, 2, and 3, and then at 3, this producer coroutine will suspend itself. So the other one is drop oldest and drop latest. So I have used drop oldest a lot. So drop oldest basically will drop the oldest value that you have in the cache, and drop latest, as the name suggests, will drop the latest. So these are 3 different buffer overflow strategies. Suspend is the default one. So that's my presentation. I hope what I went over are the basic foundations is the core material that you need to be able to use these things in different use cases. And a lot of this is, everything here is applicable both on backend if you're implementing microservices, using state and shared flows. So I hope that was helpful to you. I enjoy mentoring people. If you mentored a lot of people in actually implementing these things in their feature sets one-on-one, if you have any questions or want mentorship, you could DM me. I write a lot of content on coroutines because I've used this so much in very complex features. If you want help in testing, you could check out my website, codingwithmohit.com. So thank you so much.